So there was a book back in the 60s called Earth Abides. And the great quote from that is, men come and go, but Earth abides. And I would say, refine that a little bit down, say, men come and go, but the plants will survive. They will continue doing the things that they do somewhere, somehow. And once they're left to their own devices, they will come back like gangbusters. My name is Pat McNeal. It's hard to say what I am. A nursery grower sometimes. Plant surveys. I do botanical work. I've worked on endangered species. I've worked on giant commercial landscape projects. Anything to do with plants I've done. I've tried my hand at all kinds of different things, and more for the experience than for making money or living. So I'm lucky not to have to do that. And I've had many opportunities to do lots of different things. Opportunity comes along to do wetland restoration, I'll do it. Someone comes and asks me about planting a giant mansion landscape garden, I'll do that. So there's a lot of things I'll do. I have to go out, and the plants that I use in my nursery makes me, or I need to go out and collect them from the wild. So I've spent 30 years in the wild looking for plants. That's what got me started into this originally. When I grew up in California, where it's very dry, and the plants that I was interested in looking for and looking at, the places I liked were these little oases where there was a little bit of moisture, water. And I noticed that certain plants would be in certain areas, and the interesting areas also had interesting plants. And I noticed in landscapes in my neighborhood are like that too, is the interesting little areas, little pockets of greenery, because it's so brown and dry in California. There's little pockets of greenery where people had gone to little special effort to make these areas. So that always interests me. And then when I started fighting fires, I was thrown in with a lot of people that were interested in plants, forestry people, things like that. And that was another, I think what really did it was I was talking to a forestry guy, and he said, if you peel the bark off these pine trees, each one of them has a unique smell. Some of them smell like vanilla, some of the bark, if you flake the bark off, it smells like lemon, cinnamon, and you can identify the plants from that. And I thought, well, that's pretty interesting. I need to learn more about that. And then later on that I learned that that's another way that you can now identify plants is by the various different volatile oils in the different parts of the plant. So starting from something really basic, going to, the way that they identify plants now by their genetics is, 30 years ago, we were smelling things. They weren't in the lab, but it's the same process of identifying plants. So all the way along, I got more and more interested in plants. And then when I got to move to Texas, I started realizing that it was wetter and there was more plants and there were springs and all kinds of interesting things I never paid attention to because I grew up in the Central Valley of California where everything is cultivated. There was no areas that aren't cultivated. Even along rivers and streams, they had to put levees, so there aren't any natural river courses. I think there's one river course in all of Central California, the Kings River, that is still native riparian habitat. So we never saw that till we went in the mountains. But my family was a big outdoor people, so we traveled all over and we started hiking and seeing all those things. And I started finding sort of these interesting little habitats. And I noticed that the ones that I liked now, I realized, were the ones that were the least disturbed. They had the most different kinds of unique plants, and because so much area is grazed and mined and logged, and most of those places you have to go and look for. And those are actually where I collect seed now, because the plants that I'm looking for are usually growing in those kind of places. So whether it's Mexico, Coahuila, Tamaulipas, Brewster County in West Texas, uh, southern New Mexico, southern Arizona. I've traveled all over those areas collecting seed. They fit the same kind of uh, form, is that a lot of grazed and agricultural land interspersed with all these unique little habitats. So that's really what, looking for those, kind of trying to understand how I would find them, has been probably the biggest part of this, and driving sort of the understanding that I have and identifying the plants. So throughout that process, I have learned that that's not shared by a lot of people. And our culture as a whole doesn't value those things the way I do. And I'm kind of continually unpleasantly shocked at how minimally people care about those things that I care so much about. In fact, they care so little that it's almost, if you say anything to anybody, it's like they just ignore you. They don't hear you.
Should they care?
They should care, because what I tried to tell them is that if you don't pay attention to the plants, you're not paying attention to the greatest resource on the planet. Is that what plants are is the only, actually I would say this, plants are a 400 million year experiment in converting sunlight into various chemicals. And no matter what you think about the skill of humans it's very, our understanding is very, very limited compared to that 400 million year experiment that's still going on. And in fact, we have changed the parameters of the experiment incredibly by destroying so much habitat, that the public doesn't realize really the extent that we're dependent on these things. I mean, basically, I don't think the public really realizes that everything that we eat, the water that we drink, the air that we breathe, all these things were created by plants. If you don't have an appreciation of that, then you don't understand how the world works. The greatest thing about that is that I can die peacefully. And this is what I think about. I can die peacefully knowing that the power of those plants to do those things will continue no matter what we do. Though we sort of have this weird idea, humans, our society, our culture, that we can kill that. We'll kill that with global warming or whatever. And it's like, I'm sorry, the plants have seen worse and they have come back. It will take a time. It's not like it's going to happen in a human lifespan or on a human time frame. It's going to be a geological time frame, but they will come back. So there was a book back in the 60s called Earth Abides, and the great quote from that is, "Men come and go, but Earth abides." And I would say, refine that a little bit down, say, men come and go, but the plants will survive. They will continue doing the things that they do somewhere, somehow, and once they're left to their own devices, they will come back like gangbusters. They will evolve and fill out the habitats, because that's what they do. No matter what we do, they will come back that way. So I think that's also something the public doesn't understand very well, is the power of that system. Yeah. What I consider, the system of life on this planet. That's the foundation of it. Everything else is less important, and it really lives off of that. Animals, people, we're animals, all those other things live off the ability of a plant to take sunlight and chemically convert it into something else. Every species has a unique set of chemical manufacturing processes that we don't understand. Every plant does that. I try to tell people the good example is, let's see if I can remember this now. Humans have 26 chromosomes. Rice has 11, maybe 13, I can't remember. But we have 26 chromosomes and 35,000 genes. Rice has, 11 or 13 chromosomes and 50,000 genes. Why does rice have so much genetic variability? What is it doing with all that? Doesn't have to express that it doesn't have information to build a nervous system, an optical system. It doesn't have to have a circulatory system as complicated as ours. It doesn't have all these internal organs. It's a far less complicated organism. What is it doing with all that genetic material? What is it doing? So we haven't answered that question. Now, some of it, of course, may be genetic sequences that are old or inoperable, but they could be expressed, say, drought tolerance, salt tolerance, cold tolerance. There's all kinds of residual characteristics that may be in that genetic material. But there could be other things that we don't understand either. How they interact with other organisms, how they interact in the soil, how they interact with things like fungi, bacteria, viruses. All those things could be in that genetic material that we don't know. So every organism may be able to do that. We don't know which ones do and which ones don't. And when you destroy a prairie and there's 450 species in an acre, and it's reduced to a grazed pasture with 30 species, then you can say tens of thousands of chemical processes have been eliminated that we don't know what they did. So the amount of information there is unimaginable. The resource there is unimaginable. What could be done with that resource is unimaginable.
What about the solar farm you mentioned earlier?
Well, that's the shame about it, is that we don't value.
Go ahead and restate it.
Well, in North Texas this week, in the newspaper, there was a report that a solar farm, a piece of land had been sold, and on that land, 3,000 acres or 3,500 acres was one of the last bits of remnant prairie in Texas. Texas has only 1% of the original prairie left. 99% of it's gone. So if you want to complain about someone like Brazil cutting down the rainforest, we should look at our own house and say, hey, stop wagging your finger at Brazil because they're only following our example, which is to decimate the environment. So if you say that 99% of the prairie is gone, the last 1% is a very valuable resource because we don't know what it contains. Just because we don't know what it contains doesn't mean it's not important. We will find out in the future if it's important. In this particular case, it's an interesting case because someone wants to sell that land and put a solar farm on it, not, renewable energy source. So you have people that are concerned with these two different issues about reducing, human impact on the earth, arguing with each other which is more valuable. But the thing is, you can put a solar farm anywhere. There's plenty of pastures that you could put that in that have low species diversity. There's plenty of gravel pits. There's plenty of spaces where you could put solar on top of roofs, over parking lots. You don't have to put them on one of the last prairie remnants in Northeast Texas. And the reason is we don't know what's there. Just because we don't know what's there doesn't mean it's not there. But I could predict that there's things there.
Can academic research solve all these problems?
That's an interesting idea. That if you can solve these problems, academic.
Okay, restate it like it's your idea.
I don't know that academic research is capable, because it's not driven in the United States about just frivolously learning and creating knowledge. It's about value. what kind of crass monetary value the research has. So if people don't see that it has a value to, say, stockholders, there may not be research money available to study that, because so much of our system now, the way our government has pared down its support of research and turned it over to private businesses, there has to be an end use, something to sell, a product, before they'll start that. And if there's not, there just is, there's just not the research money there to do it. In some cases, we spend billions of dollars on the James Webb telescope, which is great. We need to know those things. But let's spend $10 billion on studying prairies. Let's do that, because nobody does that. I don't, if you looked at the total budget of all the money spent on understanding restoration, shoot, they'd probably blast that off in one rocket. The amount of that amount that is spent on that kind of research and the amount that goes up into space is like, what do we learn? I mean, we learn great things about going into space, but we need to learn these other things because we live here. I have to say that we've turned the world into a giant cesspool, and we really need to figure out how to clean it. Not so much, the research really needs to be about that more than it needs to be about, finding a new diabetes drug or something like that. That's great. Maybe if we found out about restoring those habitats, that would be on a bigger level, more important than it would be to do something specific. And that's sort of the problem of the academic world, is that they don't tend to look at things on a broad scale. They tend to look at things on a very narrow individual scale, because I think it's geared towards product development. And really, that's what a lot of academic research has turned into is product development for the companies that fund the research. And that's my opinion from the outside, not being a college educated person. I don't see that. I grew up in a college town. And I saw how the sausage was made. My folks worked at the university, and I didn't see the value to learning and understanding that they professed to offer you. They offered something different than that, and at a very high price. And I learned that everything that they talked about in college was in the books somewhere. If you wanted to know that, you could learn it. You didn't need their help. And see, that's the interesting thing I always thought about college, is like, do I need their help? They sort of make it sound like you have to have an education. But that's not. Education and learning are two different things. Education is more like you're certified or licensed to know something so that you can sell yourself, which is different than knowing something and understanding something. Those are two very different things. And I valued the understanding and wasn't really interested in selling myself and getting a job and a career. My ambition was just to be free to learn whatever I want to learn. And here's the difference too, is that the academic world sort of says you have a period of time where you are in learning mode, and then you go to another mode, which is making a life for yourself and having a family, paying your mortgage, and that's a different mode. That's not the learning mode, and I just want to stay in the learning mode. And I think that's one of the big. I think that's a big part that's missing from the educational system, is that And it's funny because then when you're in the lower schools, they will say, "Oh, we're all about. We want people to learn. We want the kids to learn, and you're free to go out and have recess and do all kinds of things." But when you get further on, it's not about like that. It's not like learning is the end goal. Is being able to really regurgitate the same conventional stuff that everybody else regurgitates. And the funny thing is the United States is actually pretty good at producing technology. And it's worse in other countries, and I think, God, this education system here is bad for understanding and learning. And it's even worse other places. That's really kind of mind-boggling. And it never would have given me, if I'd gone that way, it never would give me the opportunity to spend my life learning about plants.
What has your experience been with design professionals? You mentioned the Wildflower Center and places they need.
Well, that's another.
Start over. It's like my experience with.
Well, I've from the part of that experience that I've learned about the academic world is, and that the difference between being educated and learning and understanding is that the output of a person from that system is guaranteed sort of to know certain things, but a lot of what those certain things say to get licensed as a landscape architect or nursery grower or architect or civil engineer,
Horticulture.
exactly, horticulturalist, is that you learn certain things dreamed up. Really, what that list of certain things is really make believe, and it's dreamed up by people who are in that system, not outside that system, and they do that without consulting anybody outside. So those, if you say get a degree in horticulture, ag science, range science, ecology, you are meeting certain benchmarks that they have set, but they don't have sort of the practical world experience. So those benchmarks aren't set towards things that are actually need to be done, can be done, or are worthwhile doing. So when you're in the practical world, you say, well, it's great. Like in horticulture's example, the students out of the horticulture get a degree in horticulture is like, all right, you did experiments on this and this and this. How many plants was that? And because I've interviewed people for jobs, and they would say, well, we did, part of my experiences, we grew plants in the greenhouse. And I'd say, well, how many was that? I said 200 plants, and we broke them into 10 different groups, and blah, blah, blah. We did some research. And it's like, yeah, do you realize that we might grow 150,000 plants, and we don't have time to do research? We need to be able to grow things and understand on the fly, as they're growing, what we need to do to keep them alive. So from a practical application, those skills aren't practical. I tell people this, is like, if you got 1,000 people together, I have killed more plants than them. I've killed millions of plants. Millions. I've grown tens of millions, but some have died. That kind of experience you can't get in an academic setting, because they don't have facilities to do that. They don't run nurseries.
Yeah, but
and the people who teach aren't from the nursery business.
yeah. You gave us some real simple examples of A&M UT, do they teach plants? You know, that's, you need.
Well,
to-
you know,
Just wait a minute.
okay.
In the Wildfire Center, what I want you to say is that A&M, you checked into such, they told you to go across the street to the, you know.
Okay, yeah, I can tell you those
And,
stories.
and say at UT,
Yeah.
you found out they don't really teach
Yeah.
plants. And at the Wildflower Center, there was a greater concern about the
Yeah, yeah,
the building
okay.
than it was about the plants. And so I want those stories just like you told them.
Okay,
Just
all right.
Real simple and straightforward.
So, the example of that, not the difference between hypothetical knowledge and practical knowledge. That you get in academic setting, you get hypothetical knowledge. That doesn't really transfer. Example would be that UT, when they started their landscape architecture program, a bunch of people that were interested in and had been in the plant industry for a while went and talked to the head of the department, the new opening department. They hadn't had the first classes yet. They had planned to have classes. They hadn't even taken applications yet. And we wanted to help them with their curriculum. We thought we could help them with their curriculum. Of course, we were mistaken because they didn't even offer any plant courses. They were going to have a landscape architecture program that was going to be based on urban development and global or geographic information systems, which is basically, you know, computer operated and aided design for urban development. So yeah, they were going to produce landscape architects without any plant knowledge or any plant courses. And that's true of just about every landscape program in the United States. I had a friend that had to choose between landscape architecture schools. He wanted to be a landscape architect. He went to LSU because LSU offered more plant courses, 3 plant courses as opposed to 2. A friend of mine was going to get into the landscape architecture program at Texas A&M, and this was a couple of decades ago. But when he said he wanted to take some electives, and the electives he wanted to take were plant courses, so he could know about the plants and the materials he was going to have to deal with, the head of his department said, well, you need to go across the street because that's where the horticulture department had their program. So basically they said, we don't want to learn that stuff in landscape architect school. We want you to be in the horticulture school if you want to learn about plants. Even though, what is a landscape architect supposed to do? So you have an academic world that doesn't even, a field where the people who are going to get a degree and call themselves landscape architects know absolutely nothing about plants. And that's really odd because really that's just an engineer. So I think that sort of lends itself to the idea that you see what you see around cities and in the United States is that the way a city looks is because it's been designed by professionals who don't understand plants. So you have, you know, and you can see this in renderings from architects, landscape architects. They're these stylized, pretty pictures, but they don't focus on the plant life. And so I've had, you know, more experience with that in the past where I've worked with landscape architects on projects like the Lady Bird Johnson Wildflower Center, where we would be in meetings with the architects about, and I don't understand why the architects were there. I was kind of curious, why is the architects in this room, in this meeting, talking about landscape architecture? And I finally realized because they said they wanted to control where some of the plant material, like trees, were going, so it wouldn't interrupt the view of the buildings, so that they were more concerned about their buildings than about the plants, which is the exact opposite of what that was, because it's not the National Institute of Architecture. It's a facility that's based about plants. So we had no problem saying, at least I had no problem saying, we'll put the trees wherever, because this is about the tree, not the building. And it was supposed to be that way, but it was, like everything else, ended up being a compromise. But I was kind of shocked that would come out of that. That they would say, yeah, your buildings are nice, but we're trying to make people understand about plants and how plants and the relationships between each other and the relationship between development, urban environment, and plants. And I think that's the funny thing is that about all that is that landscape architects, and this has happened in the last 3 decades, people have started to be interested in native plants. And that's what I started out. I started out native plants, trying to, when I first moved to Austin, they were still landscaping like it was Houston. And there was azaleas, and UT had an azalea walk. In the springtime, you could go and some docent would take you around and show you all the plantings. And I thought that was the weirdest thing, because azaleas are really hard to grow here because it's so alkaline. Our water is so alkaline. In fact, people are shocked if you know how that scale works. It's a logarithmic scale. So from 6 to 7, the pH goes up 10 times. So the water in Austin that comes out of the tap is 7.6, 7.8. So it's maybe 80 times more alkaline than neutral. And azaleas don't do well. Blueberries, there's a whole raft of plants that are not tolerant of alkaline soils. And that's what they're planting. They're planting them in alkaline soils with alkaline water. And then they would say, well, let's put a foot of acid soil. And it's like, well, what are you going to do about the 800 feet of limestone that's underneath that? No answers for that. But so that actually comes up to another interesting characteristic of landscape architecture, is that they tend to change the environment to suit the plants. And the idea of using native plants is to find the plants suited to the environment, which is more effective, which part of this always boils down to money. So if you have to modify the soil too much, you're only doing it temporarily. It has to be redone periodically. If you plant a native plant that likes limestone soil, limestone water, then you never have to do that. And you only have to plant the plant. So efficiency and cost and maintenance is much better if you plant a plant suited to the environment and not try to suit the environment. I guess that's because we're people, and we'll live in horribly cold places and horribly hot places, and we'll just live everywhere. And then we'll try to build houses in an environment that suits us. But that's only a small part of the environment. When you talk about plants and outdoor spaces, that's a much greater amount of space. So to modify that becomes incredibly expensive. So that was the idea about planting native plants originally, was to find plants that would be suitable for this environment. The problem was that you had to change people's perception of what a landscape was, from what they thought it was or what it looked like where they came from, to what it would be if you used local plants. That's an easy sell in Texas because there's so many beautiful plants. There's lots of choices. You don't have to have those. You don't have to, like California, there's a lot less choices, which means that there's a lot more non-native plants in the nursery business, in the landscape business, because they've decimated the native plants, and there's a lot of smaller climatological regions. Southern California is different than the Bay Area, and In Texas, you have these big swaths like Blackland Prairie that are pretty much the same or close enough that 80% of the plants are going to be the same. So it makes it a little bit easier that way. But since I've been doing that and learning about plants and generally ecology and things like that, that I've realized that native plants really aren't the answer, because it's a much deeper question than that. Is that plants that you use for landscaping are certain types of plants based on ecology. Is that the plants that do the best, if you're selling plants to someone, if you're a nurseryman, you want to pick a plant that will grow in a lot of different habitats under a lot of different kinds of conditions. Those aren't going to be the plants that grow in very specific locations. So in Texas, we have a really nice tree called madrone with red bark, a very beautiful tree. It grows in specific habitats. Now, I know a guy that started a nursery called a madrone nursery. He's a great plantsman. He knows a lot about plants, but he doesn't ever grow madrones. He started out thinking he was going to do that and stopped, because what happens is that plant only grows under very specific conditions that are not found in people's front yards or in their lawns or in their back, anywhere. So what happens is the plants that get picked for landscapes, whether they're native or non-native, they are going to be early successional plants. They're not going to be late successional plants or climax plant species for the most part, because those habitats don't exist. When you go and do development, you build roads, you build sewer lines, you build data lines, you build water lines. All this infrastructure goes in, tears up the soil, kills all the plants off. Even if you save a few trees, the environment is so disturbed, you're basically a disturbed environment. The plants that do the best are going to be the disturbance species plants or the early successional plants. This is why in agriculture, agriculture is the funniest thing, is they don't know anything about ecology, and no one's really applied it to agriculture. Is that you're doing annuals that are all early successional plants. That's why they need water and fertilizer, and they do well under those kinds of conditions. But that is also the kind of conditions that all the other weedy plants do well under. So you're always having this competition between all these different kinds of weedy plants. If you said, let's do lower productivity over a larger area, then you could do more late succession or climax plants that would not need to be replanted every year, and eventually you would get rid of all the weedy plants, and you could do less weeding, less spraying, less fertilizing, and still produce a decent crop. But all those things are, if you think that plants are neglected by the public in all the professional fields that deal with plants, they don't pay any attention to those sort of ideas of ecology either. Botanists, horticulturists, landscape architects, restoration people, they hardly ever pay any attention to any of that idea. So what we end up with is what we end up with. You can see that it's just a giant, just disrupted environment that can't heal itself. I had at my nursery, I have a nursery, wholesale nursery, and I had two employees, a father and a son, and the father was half Otomi Indian, indigenous tribe in northeast Mexico, central east Mexico, and his early part of his life, he was a mostly subsistence farmer, basically raised everything they ate, and didn't do commodities. He just had this little 10 acres, and he probably cultivated 2. And we had conversations about this on and off, and it was interesting and kind of difficult, because English or Spanish was his second language. He spoke Otomi, and I spoke Spanish as not even a second language, probably as so we had to everything that I thought and he thought had to be translated from our native languages through Spanish. But I did learn some things that I thought were important. And one, as a subsistence farmer, it wasn't, again, black and white about what he did for crop selection. Everything that he did was based on plants that were fresh plants and plants that were storage plants. So things that you could store would be corn, beans, and squash. They stored, and that's what he devoted most of the resources of his garden to. So he had a lot of corn, and then in between he had beans growing on the fields, on the walls, and the prickly pears around it. And then he had squash growing, just like we know that lots of indigenous people did. They grew all those plants together. All the other plants that, like me and you, would grow, green, leafy greens, and things like onions, and they wouldn't grow any of that. They just collected that stuff. So they didn't waste any of their time or effort or energy growing things that didn't store, because they could collect them around their house easier than they could cultivate them. So it was a hybrid system. And I think in the world, because the people in anthropology, archaeology aren't plant people, they don't see those differences, that there's a hybrid system between pure agriculture and pure hunter and gathering kind of lifestyles, that a lot of them are some type of hybrid in between that. And that means that a lot of the plants that they're consuming are fresh, but they're the local plants. So things like chilies, once you get them established, because they're perennials and we don't see them as perennials, they know they're perennials, they don't cultivate them. They just grow, that just grows wild. So like in my nursery, I collected a tomato, Lycosporum esculentum. With Lynn Lowry, we collected it down in South Texas. And I grew them for a while, purposefully. Now I don't have to. They naturalize, they come up everywhere. I mean, they literally are naturalizing. So I have chilies naturalizing, I have tomatoes naturalizing. And so if you're a subsistence farmer and you could have plants that naturalize like that, then you wouldn't put any energy into cultivating them. You would have those ingredients or parts of your diet, and you wouldn't expend any energy doing it. I think that's one part about agriculture that sort of falls away, because the people who are in those fields documenting that don't have that plant background to understand the difference between that. So if they needed onions, they don't grow them. They go and collect them from the ditches and areas in their neighborhood. That couple, Carlos and his wife, still come to my nursery to this day and collect Vertolago, which is Portulaca oleracea, which they cut up and fry. Mostly they tell me they fry it in pork as a green. And they leave with 5-gallon buckets of that stuff. They eat a lot of it. But it's a weed in the nursery, and everybody I know sprays it and kills it. And I leave a little area that's unsprayed so they can come and get it when they want it. It's really not much of a weedy plant. But if you don't have the plant knowledge, if it's not documented anywhere, if an organization like Useful Wild Plants doesn't put that down, how would anybody know that without talking to someone like Carlos? Those people are rapidly disappearing too, because even less developed countries like Mexico are developing, and all that knowledge and skill is going to go away. So we won't understand how that cultivation works, and maybe an alternative for urban environments, suburban environments, all kinds of other areas for producing food crops. So unbeknownst to us, most of us, that there are plants. You don't have to go out and get wild plants. They're probably growing in the Walmart parking lot. In fact, one of the things that I do is that I'm so interested in this subject is that wherever I go, I look at plants. It could be the Walmart parking lot. I'm curious of what grows in the cracks at the Walmart park. And there's a specific set of species that you see. So there's value in understanding that waste places that have been disturbed, also could be productive, or we could restore them, or they could be some combination. We tend to think of things as black and white. This is an agricultural field. This is a grazing field. They could be. I would envision a place where there'd be both, but we need a place where we can train people to think that way, because we're not trained to think that way. And I would think that my background of not having a formal education has not limited me, I guess I would say, to thinking conventionally that way. It's all equal to me. It's just, why would you do it that way? We see how that's done, and how much value it has. And yes, that's the way we can feed 7 billion people, but maybe there's other ways to do this too. And maybe if we expended the energy and resources in those areas, then maybe we could produce a whole suite of crops that would grow in a less in a situation that needed less resources, less water, less fertilizer, less spraying, less weed and disease control. So that's something that we could learn from people that have thousands of years of experience, not just what an anthropologist thinks is important, but as a plant person, what we think would be important. That's sort of what's lacking. Where we live and where people used to live in the past is, we live in areas based on our criteria. Where they lived in the past may be based on where plants grow, where plants are found. Those kind of criteria would be understood by plant people, but not archaeologists. And I was told by an archaeologist that the greatest density of people in North America was between Presidio and El Paso on the Rio Grande River. And that made sense to me because it had some very useful characteristics. One, it was frost-free for the most part because it's down in a warm river valley. It had permanent water, a permanent source of water. It had enough fall to it so you could put canals, resacas, on the side so that you could water down river by gravity, like they do. Those still are no, they're not resacas. They're what's the Spanish word for the little canals they build? But they're still operating in San Antonio, on the San Antonio River. And that's why they built the Alamo where they did, because the water can be channelized and run on the plain. As the river drops down, then the canals become high enough to irrigate the terraces without any pumps, or you just open a slough and the thing gets watered. Del Rio still has those in operation, but you could do that on that river, on the Rio Grande, and it has river terrace soil that floods periodically so that you would get soil that has fairly fertile, and you could get 2, 3, 4 crops. Downhill from the Sierra Vieja, which is a long rampart of cliffs that runs 30 miles long, and it's maybe a 600-foot straight up and down drop, that has been cut by the Rio Grande. And of course, whenever a river cuts through something like that, you'll tend to get springs, and all these little valleys have a series of springs. Barton Warnock, who was a botanist and wrote and produced some wildflower books about West Texas, took me out to a ranch out there and showed me a creek, a little spring. And there was a cleomella, there's a yellow cleomella out there, and he wanted to show me that. And we went there, and he also showed me that there was, around this spring, there's a pool. And then up on the shoulders of the banks of the creek, there were these flat spots with little circles of rock. They were maybe at the most 18 inches tall. And it's like, I thought they might have been grain silos or some storage or something, from a long time ago, but Europeans had built them. But it wasn't. What they were hunting blinds. The indigenous people would lay in those things with their bows and arrows and spears. Then when animals came to drink out of the little pool, they'd jump up, and it was an ambush site. So they'd put a row of stones around there and hid behind them. And there was one on both sides of the pool. This whole area was maybe 70 yards across. And so maybe herds of pronghorn, bighorn sheep, mule deer would come in there to drink, and maybe at night, and they would hunker down behind those rock walls till they all got down there, and then jump up and ambush them. I thought that was pretty interesting is that we don't see those places, but that area, this kind of proves that area was fairly well settled. It's not settled much anymore. There's not many people out there because we live in other places, and we don't, our crops aren't dependent on, we have wells and, irrigation plants and fertilizer, and they didn't have all that. So they would plant their plants near their water sources more than any other thing. So those kind of things also, those kinds of areas also have interesting plants in them, for the same reason that the indigenous people picked to cultivate plants there. It's because they have things, water sources, extra rainfall, slight differences in rainfall that wouldn't even be noticed. In fact, where I am between Bastrop and Austin is on a gravel hill that was laid down by one of the past oceans. And there's a LCRA, Lower Colorado River Authority, has a little park called McNeal Roughs. And that soil in there is different than a lot of soil west of there. And it's one of the westernmost locations for loblolly pines. There's loblollies in there. And that soil is real acid. There's Vaccinium arboreum, which is farkleberry. It's a tree blueberry. And, those areas, it has an elevation maybe 150 feet above the Colorado River that runs through central Texas. Now, I've noticed the difference because having a nursery out there, I have to know how much it rains all the time. And I could say definitively that where 71 goes across the top of that, State Highway 71 goes across the top of that, it rains more. Not significantly, not measurable, but it rains more often. It drizzles more often at the top than where my nursery is near the river. So there's a slight variation even in the rainfall over 3 or 4 miles. And civilized people wouldn't notice anything like that. Plants notice that, and that's how they organize themselves, based on those slight climatological differences. And indigenous people would know those things too, because they're out all day in the climate over their lifetime, and they would notice those things because that's their life. That's one thing that if we were trying to talk about convincing indigenous people to understand the importance of plants, they would sort of laugh at us because they would know that because they spend their whole life is built around that. We don't have to anymore because somebody off somewhere else that we don't even know on some other continent sometimes grows those things and brings them to us. Now they bring them right to your door. I mean, people don't even have to think about where stuff comes from, plants, food, or whatever, because it could come right to your door. So what happens is we get more and more divorced from the actual environment we live in. And I think that contributes to people's inability to understand that plants are important to them. That not just plants are important to them, but the variations and gradations of types of plants and what they do and what they grow, the resources that they present. One of the things that I like to tell people, they say, why should we preserve, prairies? I can drive in my car and see grass everywhere. But there's a difference between seeing grass and seeing a prairie. Those are not the same thing. A collection of grasses is a collection of grasses. A prairie is a highly organized set of plants that is pretty much uniform from site to site. So if I go to a prairie here, if it's the same kind of soil 3 counties over, it's going to be 80% the same species because they all prefer that type of soil, that type of climate. So they organize them themselves. So forests, we have ash juniper woodlands. They have a certain set of plants that are in them. There's a little bit of variation, but 70-80% of the plants in oak juniper woodland are the same as any other oak juniper woodland. You can count on that because the conditions that make it oak juniper woodland are the conditions that those plants are competitive in. So when we go around the world, when the general public goes around the world and looks, what they don't notice is that there's this incredible amount of organization in the plant communities. And the difference is, what I like to tell people the difference is that if you had take all the building materials that it takes to build, say, a high-rise building, if you have all that material and you build the high-rise building, you have structure, steel, concrete, all those things. Then you have the water system, the sewer system, the electrical system, the air conditioning and venting system, the transportation, elevators, walkways, all that systems are put together so that they function in a certain way. So that's a building. Now, if you knock that building down, just blow it up, all the parts are still there. Every one of those parts is still there. It does not function as a building. It's still the parts, it's not the building. That's the same with a plant community. You can have the plants, but not the prairie. The plants are just an accumulation of stuff that doesn't function with any kind of relationship between them. A prairie is a group of plants that has developed and evolved a relationship between all those plants, the climate, the soil, and all the billions of organisms in the soil. That's completely different, and that's why we need to look at those things to save them, because besides the plants being important, we also have that organization is important also. And the importance to us as humans would be, how do we do things like keep things from flooding? How do we keep droughts from killing everything? A plant community is resilient to all those things, whether it's global warming, fires, floods. They're going to be resilient to that more so than just a loose accumulation, a bunch of plants that have just congregated together for the reason that there's open space. And those relationships also are something that we could study to understand how we can use that resource and that resiliency to grow crops that are less disturbing to the environment. How we could grow plants that we need. There used to be good examples of that is collection of cacao, the fruits. For a long time, those plants couldn't be cultivated, so people went out in the wilds and just collected them. Rubber used to be that way. They used to tap rubber trees in the wild until they learned how to grow them in plantations. That idea could be used for other types of specialty agriculture, because people don't want to just eat bread that's made from wheat. They want to have all kinds of different breads with all kinds of different grains. We all know the importance of eating something other than just refined wheat. We need to find out how we can cultivate those things, and what those other crops are, and what plants they grow together with to keep them growing perennially and without the needs for a lot of water, fertilizer, or pesticides. I think that's an importance that there isn't any academic field that studies that. And we really could use systematic research in that direction if we could convince someone to pony up the money to do that. That would be probably more help than just about anything that you could do in agriculture. Now, there's been some changes in things like grazing, where people have come up with lots of different ways of high intensity grazing and rotating animals through quickly and planting native grasses. But those ideas haven't really translated into food production, direct food production and crops. And and there are now places that teach that, but there aren't places that do that about plants. You can do that for animals because of the importance we put on animals and the less importance we put on plants. But plants cover a much larger area, so if you did something with that, it would make a bigger difference on a larger scale over more area. That could also be understanding the plants in a forest would also help for managing forests for lumber, for other wood resources, because as a forest firefighter, I saw that on the West Coast, and then I also worked in areas that had been logged and seen what it takes to replant an area that's been logged and what's lost when you do log an area. The interesting thing that I've noticed is that in the last 15, 20 years, the fire intensity, the amount of wildland fires, the intensity of wildland fires have grown on the West Coast, west of the Rockies, where there's the weather conditions that really set the stage for those kind of fires. If you don't know anything about plants, if you know very little about plants, you can't solve the problem of reducing or eliminating a lot of those fires. The solution is, of course, what is it with the plants that have changed that make these fires worse? It's not temperature. It's not global warming. All the things they ascribe to it, it's not those things. The real reason why fires are burning in the West is because we've converted all the forest land, or most of the forest land in the western United States, from woodlands to brushlands. And what that does is it reduces the fuel from vertically spread out over 60 feet down to the bottom 12 feet. So the biomass of any acre of forest land is now in the lower 12 feet, which means it burns more intensely. So the fires that I used to fight in the past in Southern California are now the same type of fires you see Northern California, Washington, Idaho, all these places. It's all brush now that's burning, interspersed in these forests. If you look at Google Maps, you can see what I'm talking about, because you can see the checkerboard of the areas where the trees have been cut. And it's an ungodly amount, because these forests take 40, 50 years, 60 years for the trees to regrow till they get a canopy high enough to eliminate the brush. They have to grow up tall enough so the shade of them will interrupt the life cycle of the brush below it, and they'll eventually peter out. So if you take 60 years of logging, we might have logged out 60 or 70% of all the trees on the West Coast and converted to brush. That's why the fires are so bad. They say temperature because of global warming, but I've been in Alaska where it is 82 degrees with these giant fires burning. The difference between a 2 degree or 3 degree temperature change in the environment, in the atmosphere, is a insignificant portion of the difference between 212 degrees and 450 degrees. 212 degrees is the point that water boils, and 450 degrees or so is about the point where grass and brush starts burning. So 2 or 3 degrees isn't going to make a lot of difference in that span, because plants won't burn if there's any water in them. So a plant has to get above 212 degrees before it's even ready to burn. That's the temperature that the water boils and is ejected from the fuel as steam. Anything below that won't burn. We used to have a trick that we did with on fires. We'd get the new guys in the first fire, and at night it got cold in the mountains. A lot of cases we'd have a fire and we'd be standing around the fire. They gave us these cups of coffee. They always had coffee for us, coffee, which is great. Free coffee, have some coffee, drink some coffee, stay awake. They'd give us those old wax paper cups of coffee. You could fill up a wax paper cup that's flammable. Wax and paper burn very well. You could put coffee in that thing, fill it up, put it in the hottest fire you can imagine, and the paper does not burn. Paper does not burn because there's water inside it. It will not burn until all that coffee is evaporated. It will char the outside of the paper, but that paper will not burn. So that's the same with fuels in a fire. Unless they're totally dry, and you can see this if you have firewood and it's not properly cured, it'll snap, it'll pop, little stuff will ooze out the ends of the logs. That's all the water trying to escape, and it won't burn until all that water's gone. That answer that I just told you about the reason the intensity of the fires are so bad is a novel idea, because it's based on plant knowledge, not on fire science. I actually studied fire science, but there's nothing in fire science that would tell you or lead you to that idea. The only way that you're going to reach that conclusion is if you know something about plants. So knowledge about plants that you could find in like Useful Wild Plants encyclopedia could help with those kind of solutions, plant solutions. Another example of that is erosion control on flooding areas. We have a lot of problems in Texas with flooding. And a lot of engineers are conversant and understand hard, they call it armoring a creek bank. And what it is, it's piles of rock, riprap, which is wire baskets filled with rock, concrete. In severe flooding areas, that's what they're going to put on the sides of the bank to stop them from eroding. The problem with that is that those last 20, 30, or 40 years, then they start to degrade and have to be redone. The answer to doing that is plants. You can plant plants that are at the least, if you do this properly, will hold the slope, stop erosion, as well as any concrete or rock solution that you can have. But the big difference is once you pour concrete or put rocks in there, from the moment you are done, from that point on, it degrades. If you put plants in there, and the time that you're finished, from that point, it gets better because they reproduce and make more plants. So concrete doesn't reproduce itself. So if you lay concrete, all you get is that. If you put plants in there, you get more plants. So the actual job that you do gets better with age on its own without any further investment from us, if you have the plant knowledge to do that. The people who are in charge in a lot of cases are engineers of doing that, and they don't know anything about plants. So their solutions are always these hardscaping solutions that are going to fail eventually. Where if you do plants and you do it right, they will never fail. Again, that's another example of plant knowledge, extracting plant knowledge that we can use to make our lives and the environment better for it. Because of course, if you put plants, there's other advantage of putting plants in a creek bank. One, a great one, is that it reduces the amount of contaminants in the water. So those plants on the base are going to be filters where concrete doesn't filter anything. So the plants are going to make that water that's running through that creek, it has to go through those plants. The plants will use up nutrients. They will tie up certain contaminants. The water in the creek will be clear and more animals, and it's easier to use for filtering and cleaning. So the plants do, besides being a better choice just physically of holding the bank, they also create better water quality. So like the city of Austin has realized that in a lot of their projects where they're not doing hardscapes as much. And there's always been this big struggle back and forth between the engineers who want to do the hardscaping kind of projects, and then other parts of water quality within the city that want to do plant solutions. And in a lot of cases, the plant solutions work as a long-term solution much better than any of the hardscaping solutions. So this is just another example of a plant, an unusual or usually unthought of plant solution, using plants to solve a problem in an urban environment. You could say those things if we spent our time and we had people that were trained and understood that. There's a lot of other solutions that could be used for parking areas and things like that. I've even worked on green walls for building a wall system that you could put on the side of a building. The real use that we were designing was putting on sound walls on freeways, because here's the interesting thing is that we know that a urban area heats up from the heat island effect with all this with no plants and a lot of concrete and asphalt, absorbs a lot of heat and then re-radiates that heat back out in the evening. So the environment in urban centers is much hotter than out in the rural areas. You can mitigate that by doing plants, but unless you have the right plant knowledge, you don't really think about why that is. Why that is important. You can do treatments on a hard surface, like paint it white and it becomes reflective, right? All right, a reflective surface doesn't absorb the electromagnetic radiation, the infrared. It just sends it somewhere else. If it's absorbed by a plant, that infrared part of the spectrum is absorbed and converted to chemical energy. So that heat is actually taken out of the atmosphere. It's removed. So it cools by removing it, not by moving it around. So you can actually lower the amount of heat in an area by planting plants. The other thing that plants do is that the most difficult particles of air pollution that are in the air are what's called PS205. Those are particles less than 2.5 microns. And they're the ones that lodge deeply in your lungs, way down in the little teeny pockets that your lungs can't expel normally with the villi. So they get down there and they can cause all kinds of problems, emphysema, lung cancers. They're irritants, and the irritants in your lungs can cause multitude of diseases. Interesting thing is, plants are always respiring. They take in air and they release air. Take in oxygen in the daytime and they release CO2 at night. The stomata, the little openings on the leaves that absorb that, can absorb those PS205 or 2.5 size particles and remove them from the air column. With enough plants, the air gets polished of those and there's less to breathe. So we thought, if you wanted to sort of maximize the cost of, or the value of putting up walls of plants, the best place to do that would be on a sound wall. Replace a concrete sound wall with plants, because it will modify the temperature, it will clean the air, and then thirdly, because of the leaves, they will absorb audio energy, the noise that the road makes. Those sound waves will actually be dampened by the leaves of the plant. They won't be ricocheted around like a sound wall does. They'll actually be absorbed. And we and my partner hypothesized that if you change the size of the leaves and the density of the leaves, you could actually maybe tune the wall to certain frequencies that are hard to eliminate. Low frequencies travel further and go over sound walls. Well, maybe you could take the plants, test them to find out which ones do a better job absorbing the lower frequency tones, so that people don't have that low frequency rumble that you hear in the 1 or 2 blocks next to a really highly used freeway. So there's more that, there's solutions in there besides fixing the concrete or fixing the wall. There's a plant solution to that. What we need to understand is that there are resources beyond just say these plants are edible or these plants are for medicine. There's all kinds of other uses that plants can be put to in our environment to make it better. And if you don't approach this from a broad understanding of all these fields, you really can't synthesize that into a workable solution. So as far as the fires go, talking about what you'd have to do to eliminate and reduce the fires in the West, it's a simple process, is that you just mow the brush down. And they do that in a lot of places under right-of-way easements, high tension lines. You can get in most of those areas and you just mow the brush down. In critical areas where fires are the worst, you can strategically target certain areas and clean those out. I mean, I hate to say this, but it's kind of like the idea of taking the rake and raking the leaves. Now, that's probably not accurate and very simplistic, but this is the same idea. You remove the biomass from that zone so that the fire has less energy to move from one area to the other. So you could preemptively do that around cities, houses, roadways, to create areas where you could evacuation routes, canyons where it's the fuel density is real high, wet areas. There's a whole way to, if you understand anything about plants and the plants that are there in that environment, how to manage for them, you could reduce. I actually did some rudimentary calculations. You could reduce, I would guess you could reduce the fire danger in California by 25 to 50% with about $5 billion. They spent $5 billion just on helicopters and stuff like that last year. That's reactive. Cleaning out the brush means they wouldn't need those things. And people would be safer. Their houses wouldn't burn. So they wouldn't burn up when they're trying to evacuate the little towns in the mountains. So there's solutions there. It's more about understanding the plants than it is about any other thing. But if you talk to people in fire science, they don't know that about plants to apply those as a solution. And that's an example of a culture that doesn't value plants. We can't take advantage of what they offer to us to solve these really kind of tough problems. And the great thing about what I like about plants is that it doesn't take much because they have 400 million years of reproducing themselves. Once you get them started, they're just going to go on their own. You just have to figure out how to do that. Just need to do some research, need to do some investment. There needs to be people interested in doing it, and there's got to be public support to understand it. Once that is all in place, which is a big ask, we could handle some very serious environmental problems simply, permanently. So I think that's why I'm interested in it. Because how many different solutions were there in that? There was like 2 or 3 or 4 with widely separated different fields. But that's sort of the personal education that I've taken that I couldn't have gotten at a university. The value of the use of wild plants is we have to have some way to transfer this knowledge and also to publicize this knowledge. One is that a lot of plant knowledge that I know of, the old guys, people we've known, like Lynn and Benny Simpson, Lynn Lowry, Barton Warnock, they passed away. That information got transferred from person to person orally, but a lot of it got lost. So the value of what's being done in useful wild plants is to put it where it won't be lost and put it all in one place so that people can use that, learn from that. But also, I think it is a way that people can build on what's in there. So if you give a broad overarching look at this thing, then people can do more specific information on things that they're interested in. I'll give you an example. We had the big frost last year in 2021 in February. Froze out of my place. It was it was 12 degrees, 8 degrees in that range. 12 degrees outside temperature, below freezing for 3 days at least. There's chili pekins out there. They did not die. They are coming back from the roots. So we have a huge industry that produces chilies, all for food. Nobody there, everybody thinks that chilies are annuals. They plant them like annuals, they grow them like annuals. They don't know that they're perennials. They get as big as trees. That's an example of agriculture not knowing the proper plants and how to use them. Because if they did, you could plant chili pekins, they would be productive. They're starting to, those that froze down have come back and produced chilies last year, even though that's way below what anybody thought they were cold hardy to. They're coming back, they produced fruits last year, they're going to produce more this year, and they don't have to be replanted. And they're huge rootstocks under the ground. They don't have to be weeded. They're big enough to grow out through the weeds and everything else. So those circumstances have shown that that knowledge is useful if it is somewhere someone eventually in some corner of the food production system that we have in this country will realize that's a value that needs to be somewhere where that is accessible, because we can't all see that, have chili that survives those kind of temperatures on the street where they ride their bicycle every day. So the value of that information, there's always value to every bit of information. Really, it's like anything else. It's like, what can you, the value of that information is something you may not know at the time that you do it, you need it, but eventually someone will find a use for it. So if you have that information there in the volumes of the encyclopedia, someone will find a use for it, or it will be a starting point to use that information. And the other thing that it gives you, just looking at that stack of books, is that there's a lot of plants and a lot of knowledge that nobody knows anything about, except for this small fraction of the public. Nobody really knows or cares. So it's also a learning tool that way, is that you can say, look, that's just Texas and the surrounding states. What is that? 15,000 pages you're going to end up with, something like that? 1,000 for 14 books? 1,100?
We're not saying how many volumes anymore.
Oh, really?
I mean,
okay.
nobody knew when we began this. I mean, you just sort of threw out.
It kind of grows. Well, so here's that's the funny thing, is that the closer you look, the more you're going to find. So the more you look, the more information you're going to find, and and as you catalog it, you're going to add to that.
We're pretty close. But if we had the funding, we'll probably revise the first several volumes. If we get enough money to hire some writing teams, we'll probably redo the first several volumes.
Right.
Just because there's more, and we're saving all the new information on all the species that have already been published.
Right.
So.
Well, I think that is the. So the value of it is not just one or two things. There's a lot of values that we can think of now, but we're not going to think of all the values of that information. Someone else is going to do that. That's the point of information. The information is not just like, what can I think about it and just be that thing. Maybe it's going to be something else. Maybe someone else is going to be inspired and have another idea how to use that information. So information has a value intrinsic to itself. Just having it. Mm-hmm. Otherwise, it's lost. Movies have been lost. Recordings have been lost. It needs to be recorded someplace that's information about plants, so it's not lost. So it can be used. Even if it goes out of date, it's important. I look at one of the more interesting sources of information that I find is U.S. It wasn't the USDA at the time, but it was the Department of Agriculture put out a yearly book for farmers with all kinds of information about new crops and new different techniques for growing crops. It's all out of date. But it's interesting to see that, because we have forgotten a lot of that information. And it's not when you try to become efficient at food production, you pare away a lot and lose, right? So that's how you become efficient. But all those other ways of doing it have value in another place, another time, and other circumstances. So that actually goes back to what rice has all those genes for, is that it's saving information in its genetic material in case the environment changes. So that's the role of. See, look, here's that comes to that comes to a great point that had just occurred to me. Right, plants are a lot smarter than us, because all that redundant or non-useful information that it could need in the future, it's got found a way to store that just through trial and error. And we're not even smart enough to think of that yet. You know, how do we save this information? Not because we need it now, because we'll need it in the future. So that's what the seed repository up in the Arctic is like. We don't know that we're going to need these, what we're going to use these seeds for, but we may need them in the future. Let's save them. And that's what basically what the Useful Wild Plants is, the same sort of organization, is that it's a repository of information. It may not be something that you're going to need and use right now. It may be something that you'll need and use in 50 years, or parts of it. So I think to me, I would see that as the biggest value of the project. It's just the documenting of that. And the great thing about the point of time that we live in now is that there are ways to record that and save that information. Lord knows they're saving all kinds of other junky crap on the cloud that will last for 1,000,000 years. Why not save something useful?